This is Unit 5, Review Problem 30. And it's basically we want to talk about Type 1, Type 2 errors. That's where we want to get. So there's a series of problems. They're all good problems, and this is a good review for the test. You'll probably have some multiple choice questions about this. Okay, so what we have is we have two institutions here, so to speak. We have an auto parts company that they say they advertise, but I think what they do is they sell, right? They advertise, but they also sell a special oil additive that will make the engine run smoother, cleaner, longer, with fewer repairs. So we're going to have to assume that they're a credible organization and that this is probably true. Okay, but an independent laboratory decides to test their claim. So this would be like a magazine like Consumer Reports. So they may decide that they want to check this out and do an independent study. So they arrange to use a taxi cab company, and the cars are randomly divided into groups. The company's mechanics will use the additive in one group of cars but not in the other. Okay, at the end of the year, the laboratory will compare the percentage of each cars that require engine repairs. So even though they talk about run smoother, cleaner, longer, these things could be measured. If you know about automobiles, they could be measured, but it's probably easier to measure the number of repairs, and that probably has the biggest impact on customers. Okay, so what we have is an experiment. Just to make a quick connection to the previous semester. So treatment 1 would we would use the additive, and treatment 2 would be no additive. Okay, and they didn't say, but we would have to assume a legitimate number and that those were randomly assigned, and they did say that. So they made two groups. So that's what we look for a hypothesis test. And over here at the end, we're going to measure repairs. Okay? So the first one is the answer would be experiment. Okay, so now would it be a two-tail or one-tail? So it could be a two-tail. Like if Consumer Reports would probably get a lot of recognition if they were actually able to prove that a company was so deceptive that they promoted something that actually harmed your car. But that would destroy the credibility of the company for all of its products. So it's likely that that's not the case. It's likely that they're selling something that has marginal impact but not significant. So I think here what we'd want to do is a one-tail. Okay. Let me further explain. And we need this anyway to do the error analysis. Let's look at what the structure of the hypothesis test would be. So first, what we'd want to do is we want evidence that it works, not evidence that it doesn't work. We want evidence that it works. So what we're going to say is that the additive does not improve performance. Okay, and then here we're going to say that the additive does improve performance. All right, so here P would equal some proportion. Let's just call it the proportion of current level of repairs. And in here we would want to say that the true population, if you use the additive, would be less than whatever that proportion is. Typical number of repairs for a car. That's going to vary by the age of the car. Okay, so that's the structure of the hypothesis test. So now let's look at problem C. By the way, if we did this, this would be one tail, and it would be to the left, right? Because it's less than, it would be to the left. We would be curious to know if it was the number of repairs were less than what we expect. Okay, so what is a type 1 error? So I always have to say first, a type 1 error, so I start by saying HO is true. I always start with truth. So what HO is true, so what kind of mistake can we make? Well, we reject it when we shouldn't. Okay, so in this case, a type 1 error would be the additive do not work, does not work, but we conclude that it does improve performance. Okay, so that would be really bad for the consumers, good for the company, bad for the consumers. Okay, and D, now how can I figure that out? Well, I go back to a type 2 error, and what I do is I go back to HO and say, well, in the first case, if it was true, now I say is false. Okay, so if it's false, we should going too fast. We should reject it. Right? If it's false, then a good test would reject it. So we fail to reject it. Alright, so let's think back. Now let's put it in context. So what we're saying is the additive does work, does improve performance, yet we conclude that it does not. Okay? Alright, so now E wants to know which error is worse. Well, I think that depends on your perspective. Alright, so in the context of this, from the car company, right, for the parts company, let's say the parts company, what would happen? A type 1 is that it actually helps them. It doesn't really show improvement, or the improvement, maybe there's some improvement, but it's not statistically significant. It could just be due to random sampling. So in which case they still have a product and they sell it and consumers think they're getting value when they're not. Okay, on the other hand, type 2, the company has a product that works and it would be good for the consumers, and maybe the consumers would want it if they knew that their cost of repairs would go down if they used it. It might be a good investment, but the information says it does not work. Okay, so I would say for the company, a type 2 error is what do they want to know? Make sure I answer the question right. Is more serious. From an economic point of view. What about from a consumer? What about for the car owner? Well, I think that a type 1 error is worse. This is my personal opinion. The reason is that I don't like to get ripped off. I don't think anyone does. I don't want to spend my money on something that isn't going to help me. Okay? I also would be disappointed to find out that there was an additive I could put in my car to improve its performance and to reduce my cost of repairs. So both errors are kind of serious, but I probably would say a type 1 error is worse, is more serious. Not that the other one isn't. It's just more serious. Okay, now the reason I showed this is because I think the answer that authors use is the first one. But on a test, I'll take either answer, but you just have to have a basis. So make sure you have a reason for the claim. Don't just say type 1 or type 2. Give me a reason. Think through it and justify it. Okay, finally, if the cabs with the additive do indeed run significantly better, can the company conclude that the effect of the it's the effect of the additive? So the first part of F is yes. Yes, because they used a controlled experiment. Right? That's the only time in this course where we've seen cause and effect. What are those requirements again? You have to have random assignment. What else do you have? You have to have replication. And what else? You have to have control. And they did. They controlled all of the factors, and they used a placebo for control as well. Okay, so that's the first part. Now let's look at the second part. Can they generalize this result and recommend the additive for all cars? Well, okay, not really. Because they tested only, now let's just double check, but I'm pretty sure it was only taxis. Yeah, a taxi cab company, so only taxis. Only taxi cabs. So taxi cabs get a lot more wear and tear than some cars. So it could be that a car that isn't used to drive very far, you might not see a significant reduction in repairs. So you have to be careful generalizing. So remember, this is all about the population of interest for the study or the experiment. Okay, and that has to do sort of like where you sampled from. Okay, so I hope that helps. Good luck.